Hello and welcome back for the fourth phase of our Efficient Frontier project. This will be the final phase. In phase one, we went to Yahoo Finance and we gathered data for 4 stocks. We calculated the returns for those 4 stocks. Then in phase two, we calculated different statistics like the daily return, annual return, daily standard deviation, annual standard deviation, correlation, and covariance for all 4 of those stocks. All right, in phase three, we went forward and we calculated the return and standard deviation for the entire portfolio of these 4 stocks. All right. In phase 4, we're going to actually draw the bullet graph of the efficient frontier. We're going to do this by finding the most efficient portfolios with all of these different target returns. So there's 3 different ways to make the efficient frontier. All right, we can either find our minimum standard deviation or minimize our risk for a given level of return, or we can maximize our return for a given level of risk, or finally we can maximize our Sharpe ratio. All right, so what we're going to do is we're going to minimize our risk for a given level of return, and this is going to give us a nice bullet graph here. Okay. So we're going to do this first by installing Solver. All right, if you don't have Solver, you need to go to File, and then Options, Add-ins. Down here where it says Excel Add-ins, click Go, and make sure that you've checked the Solver add-in. All right, click OK, and that will put Solver on the Data ribbon. Right? If you're in a Mac, you might have to do it a little differently. There may be a Tools button here, and you can just click Tools and go to Solver. You may have to go to Options and install it. If it's not in the options, you may have to actually go online and Google search for Solver. It may also be easier to save your progress that you have so far and go to a school computer or laptop that already has Solver pre-installed. Okay? So now that we have Solver installed, we're going to go ahead and open it. And here you see that my, I'm sorry, I'll show you my face. My parameters in the Solver have already been saved. Okay, so let's go over these parameters to get a good feel of what's actually going on. First off, I'm going to set a few constraints. All right, so the first constraint, that cell H8 equals 1. Cell H8 is basically a sum of how much money I have invested in the 4 different stocks. Okay, so if I have 100% invested, it means all of my money from my portfolio is invested in these 4 stocks. Okay, if I have less than that, nothing's really making sense. If I have more than that, then I'd have to borrow money to actually do this. Okay, another constraint is that J22 equals M22. This means that my return of my portfolio is going to equal my target return. Okay, we'll put in a target return in just a second, and this is going to basically minimize my my level of risk. Okay, so our objective here is to minimize cell J23, which is our standard deviation. Okay, so Solver is going to minimize our risk while keeping our portfolio return at our target return. Okay, and keeping our portfolio weights equal to 100%. How is it going to do this? It's going to change how much we invest in the 4 different stocks. Right? So by changing cells J2 through M2, or how much we've invested, then this is going to change throughout the entire spreadsheet, and it's going to change our return, it's going to change our standard deviation. Hopefully what we get is minimized standard deviation for a given level of return. Okay? There's one other option we can do here, and we can either click this box to make the weights positive or unclick it to allow them to be negative. So the way we can interpret this in this setting is that if we have the box unchecked, it means that we can use short selling. All right? So particularly in the case of Chesapeake, you'll see that we have a negative expected return. Okay, so it makes sense to short sell Chesapeake. All right? And so if we get a negative weight on Chesapeake, it's not going to surprise me, because that's basically it's basically Solver telling us that to maximize or to minimize our return for our risk for a given level of return, we're going to want to short sell this. Okay, we still need 100% invested. So however much we short this, let's say we short it by 5% of our portfolio, meaning if we have $100 to invest, we're going to short sell $5 of Chesapeake Now we have $105 to invest. So between these three stocks, we're going to put $105 in. Okay? So let's go ahead and put in our first target return. All right? Now, one thing to keep in mind, if you have disallowed short selling, then you're going to need to look at your efficient frontier, and you're going to need to only input target returns between the highest and the lowest returns. Otherwise, there you can see Chesapeake. Otherwise, you're not going to be able to your solver's not going to return anything meaningful. All right, because if you don't short sell, then you can't earn more than your top expected return, and you can't earn less than your bottom expected return. Okay, so we're going to allow short selling, so that's not going to be a problem. Still, I'm going to start off in the middle here with a 20% target return. So if I put in 20% as my target return, now what I'm going to do with Solver is I'm going to minimize my standard deviation for a given level of return, 20%, by changing these weights. All right, let's go ahead and do that in Solver. I'm going to solve this using a nonlinear algorithm. Simplex typically uses something linear, which, since we're dealing with so many complicated functions here, a nonlinear is going to be best for us. Don't worry about the options. That gets a little too complex. All right, here we see that Solver found a solution. If we had made any errors throughout the previous three phases, Solver's probably not going to find a convergent solution. So here we can look and we see that we're short selling 3% of Chesapeake. We're putting 28% in Amazon, 38% in Chase, and 36% in Walmart. All right, so even though Chesapeake had a negative return with a very high standard deviation, it's still giving us a little bit of diversification benefit because it's not perfectly correlated with the other three, and that's why we're putting it in the portfolio. Okay, so you'll see that this gives us a standard deviation of 16% for a return of 20%. What I'm going to do is I'm going to go ahead and copy this standard deviation cell and put it in the standard deviation column of my portfolio solution here. Now I'm going to want to paste the value. Okay, same thing with the weights. I'm going to go ahead and take these weights, copy them, and I'm going to paste values. Right? So this basically tells us for a 20% expected return, we need to invest 28.5% in Amazon, 38% in Chase, etc. Right? And that's going to give us a 16% standard deviation. You can see that red dot is plotted now on our efficient frontier. So let's go ahead and do this for 0 through 45, and ultimately you're going to get a nice, pretty efficient frontier that rounds all the way around your 4 firms. All right, so hopefully you can do that, and I'll see you in class later. Thanks.